convenient. And be ethical here, people. Be ethical. I need to say that. So there's another thing. So you are able to. This is like show it on the other screen. Come on. Microscope view. So this is like a magnetic holder. So you can screw this against the wall and just connect it to a USB-C. So you will be able to have this conveniently charged and take it whenever you need it to go. And another one could be this, and this is like a fingerprint. So it allows you to scan and enroll your finger on the device, and you will be able to disable an alarm, for instance, or turn on the fast Wi-Fi. you can figure it out. So it allows you, these devices allow you to interact with Wi-Fi, with Bluetooth, yeah, with all sorts of communication stuff. Okay, telephone. I have. Where would you recommend a fellow European to order it from? I know in Eindhoven. So let me get a screen. Tinytronics.nl. I don't know if they ship like European wide, but this is at least for the Netherlands. They have some delays, and I saw that they were so search for M5. Selling a lot of these, so Atom Light, Atom Matrix. Do they sell the? Yeah, it's actually reasonable prices if you bear the shipping in mind. So if you want to get it fast, this would be my shop of choice. Maybe they even have, let me see, M5 stack. Store, local store. I don't know if they somehow show you where to buy their products, where to buy, AliExpress. Yeah, these are just people that created the stock and are selling it themselves. But yeah, I think you might have to buy some too. What, Joseph? What do I need to? You need to buy some, or I need to buy some? I think I have quite some already. Okay, we were about to create a cell phone. So I have two phones here. One is a Nokia 6600 and the other one is a Nokia 3310. So let's get a SIM card. Must be making a mess already. Yeah, this is a converter piece. So adding this together, inserting this. Where's my battery? Must be battery here somewhere. Yeah. Okay, works. Let's turn it on. Make this a little bit higher so you can see both of the screens. So I charge them the entire day. while it's booting. Oh, I heard my audio is very low. Oh, odd. Okay. Okay, this one is started. Type some time and date, whatever. And I even created this epic picture of my keyboard. So, so I have two telephone numbers. So let's first see and do a basic test. So I'm using burner phone numbers. So one is one, I don't know. Okay, dial. So this is the other one. So both numbers are working. Let's try it the other way around. So okay. So both numbers work. So this is like the first test that you do. See that your numbers are okay. So what I need to do now is mark them somehow. So this one, okay, let me first get a marker to mark my sims. CD marker, that should work. Okay. Okay, so this one, I have a, let me see. So this one is the 19. So 19. And then this one must be the 8, 6. Okay. And look at this funny cow. Let me get a sticker as well, because I cannot look at the inside of the. Getting one of those fancy Dymo stickers. Yep. Because I know if I do not do this part, I will mess up. Definitely. So add a sticker, and this is 19, so this is 5. Okay, so number is on the back of the phone. So I have worked on this for quite some time, and if you look at this device, I thought, well, the connectors are on the bottom, and it should go in like this. And it did. However, it did not work. But after a day of testing all kinds of AT commands, it turned out it needed to be in like this. So the other way around. So the notch off needs to be on the outside and not on the inside. So there's two devices that I have here. And I need to zoom in a little bit. So where are you? So looking here, maybe even a little bit lower. So this states microphone enable mic-en, and those are two pins. So let me get something to point at it. So these two pins are not connected. Yeah, there's an engraving to show the orientation, but it is not very, yeah, it is. Then I did not look careful enough. Very faint, that's correct. So these are not connected. So I figured out that the device was not working. So this is the module. It's a SIM 800L, and it has a microphone. So this is where the microphone is connected on the outside, but there's no speaker on this module. So what I did is they added a 3.5mm jack to be able to put in earplugs to listen to it. But if you insert this, it will still use this microphone. So by soldering this wire, you disable this microphone and you enable the microphone that's in the wire. So if you're using like for instance the Apple earpads or whatever, like this stuff, there's a microphone inside the cable. So we need to connect the jumper, and fortunately I already did. So these two, I can add or shed some light. So these two connectors, two aisles are connected. So use a little bit of solder on the back. Should have cleaned it a little bit, but doesn't matter. And this allowed me to use the cable to do the communication. So then if this one is connected, I need to get the card from this device to this one. Okay. There's like a click to it. So microphone enabled. There's a GSM antenna, but there's also a connector here to connect an external antenna. So as this is inside the entire stack of modules, it is plastic, however, and there's like some opening in the circuit board to be able to transmit and receive. But if you want to have an external antenna, that's also possible. So you can add like the tiny MCX to whatever on the outside and attach a GSM antenna to the device. So looking at this, where's my Arduino? Arduino. We need to connect this device to an M5 stack. Okay. So connected it. So there's now like a blue part under the gray part. And we go to M5 stack to see how this module works, because we don't know. I don't know. So product. So this is a module, and this is the GSM module, and there's also an LTE module for 4G, by the way. But 2G still works. So with voice, speaker via G25. This is a different module. Where's the other one? SIM 800. This is the one. Yeah, the red one. So there's an RX, a TX, and a reset. A microphone, head plug, antenna, SIM card, and that's basically it. So this is how, oh, sorry, you're not able to see what I'm doing here. So let's move to the screen view. Zoom in a little bit. So this is the module, SIM 800. It has like TX, RX, and reset. And it's a 2G network that features 3.5mm microphone. Works on 3.8 volt. Okay. So we need to create a program. Sample code for sending SMS, AT, transparent network test. Okay. What is this? So this is already a piece of code that we can just copy from their website. So this is the Arduino software. So let's start from the beginning, because this is not installed by default. So put it back on Arduino Uno. Now we go to board, board manager, ESP, and we're going to remove this one. Okay. And what we need to do to make the M5 stack or the ESP32 work on a Arduino IDE. So Arduino, tutorial. So you need to download the Arduino, and what you need to do is add this specific line, which is on the M5 stack side, to your Arduino IDE. So going to the Arduino again, and if you go to File, Preferences, there's an additional board member manager URL. So if I remove this one, which is by default, and I go to boards, board manager, and I search for ESP32, I do not find any boards. So to make this work, we need to add this specific line, which adds a special repository to the Arduino. And if we now go to the board manager and we search for ESP32, we see the expressive systems being part of it. And it shows all the different numbers. So if you have like code that's specifically for a version number, you can install the oldest one. But like for M5 stack, you can always install the latest. So we're installing 104. So install. And if you have questions, remarks, just shout them out in the chat. So it's installing all the tools, boards. But this is just the software that is used for the ESP32. So this will not only do the ESP, the M5 stack, it will do all the different ESPs. So installation almost completed. This is closed. So if I go to the board manager, it did not only install M5 stack, which is here. So this M5 stack core, M5 stack fire, M5 stick, but also the Olimax. Yeah, we're adding a GSM to M5, correct. The Node MCU, Adafruit Feather, so there's like all different kinds. So you added all these to the Arduino IDE to use. So if we're using the core, which is the gray one, ESP is like a model number of an expressive chip. So you have the ESP8266, which is a smaller version, and you have the ESP32W room, which is the faster version, the basic one, and there's an ESP32W rover, which is the faster version, and there was some vulnerability found in older versions of the ESP, so there's a newer version now as well that mitigates that specific issue. So ESP is like when you have a Volkswagen Golf. A Golf is ESP, and expressive is Volkswagen. So now we only set up the software to program the chip itself, but M5 stack is not simply a chip. It comes with a micro SD card. It comes with a audio, with LEDs, with LCD, with all different kind of things, buttons, maybe a 10 degrees of freedom sensor. So you need to install that as well. So one part you install using the board manager. So we are using the gray version of the Arduino, which is the not the Arduino, of the ESP, which is the core. So I'm selecting M5 stack core ESP32. So selecting that one. And I need to go to libraries. So include library. And if I go to manage libraries, I need to install M5 stack as well. And this will show up a lot of libraries. So these are libraries that are built by M5 stack themselves. But those are also built by people that created additions to their libraries. So you need to see which one is required for your project. So if you look here, so M5 stack, just plain M5 stack without anything else, is by M5 stack. So this is made by the vendor itself. library for M5 Stack core development kit. See more information, http //m5 stack. So this is what we need to install. So install latest version 030. So installing. Now you see it is installed, but there's also like an SD updater. M5 Easy made by Rob Gongrijp is a very cool menu system that you can use. Like you only have 3 buttons, but what if you can make like a Total Commander or Norton Commander out of this M5 stack? There's stuff for the Atom. There's graphics stuff. Yeah, all kind of projects that help expand the functionality of M5 Stack. So we installed Arduino. We installed the board for the ESP32, and we installed the library for M5 Stack. So those are the 3 things that you need to install if you're not using the UI flow that I talked about last week. So, okay, this is done. So now we have a screen, and it always starts with a setup, which is only started once, and a loop, which is started in a loop. So this is where you do the initialization, this is where you run your program. So now we're going to flash the software on here to be able to do the test. And if we go to example, you see all the stuff that is in here. And this, it's hard to read as small letters, but I will tell you what it is. Arduino over the air, Bluetooth serial, domain name server, EEPROM, ESP32, asynchronous UDP, Azure IoT Arduino, BLE Arduino, ESP-M DNS, FFOT, HTTP client, HTTP update, NetBIOS, preference, SD card, simple BLE, SPI, SPI, FFS, ticker, update, web server, Wi-Fi client secure. So these are all functions that are default in the device. So if I go to ESP32, I see analog out, camera, chip ID, deep sleep, ESP now, a free real-time operating system, GPIO. So I can select all other stuff on here. Preferences, simple BLE. So this will already get you started. But since we're not using on a standard M5 stack, but we're using the Shield. We're using the software that they suggested us to use with this device. So let's go to Sim 800. So this is the factory test. Sim 800 factory test.ino. So I go here, select raw. So this should do it. There's a loop and there's a setup here. So this should be an Arduino piece of software. So I'm copying this and I'm pasting it in this one. And what we now need to do is we need to flash this device. And we can do that over the serial cable. So if I insert this one and I go to Device Manager, this is a trick that you really need to do. If you're running on Linux, it's probably something like def tty USB, and same for OS X. So what it states is there's a UART. It's by Silicon Lab CP210X, USB to UART, COM11. So if I remove the cable, it is gone. And if I put it back, I see it again. So I know that by removing the cable, I know that this COM port belongs to the M5 stack. So why do I need to know the COM port? Anyone a suggestion? For the code. What do I want to do with the code? Actually, sometimes you connect to the COM port for reading the code, the API key, or for configuring the port. But in this case, we need to tell the IDE which is a serial port to use to put the software on the M5 stack. So what I need to do is I go to Tools. There's the board that we already set up, the M5 stack core. This is the speed which we use to communicate the cable. So if you have like a crappy cable, you could down the speed a little bit. And it's 80 megahertz or 40 megahertz. There's a flash mode that you can use, like a quarter or doubles. You can select a certain partition scheme, and that's what do you think is more important? Do you want over-the-air updates for newer versions of your software, or do you want to have like a piece of uh, um, a part of storage on the device itself, so like a file system on the device. So having the red M5 gives you both, while the gray one probably makes you decide whether you want one or the other. And do you want to debug the information? And this is the COM port. It already shows me that it's COM port 11. And it tells me that there's another device in my home, the Decennium batch, which I'm able to flash from the Arduino itself. So this is configured correctly. So what I'm going to do is I'm going to compile. So while compiling it, I need to tell it where to store it. So GSM factory test save. So it just saves the code, and now it's compiling. So it tells me compiling sketch, and there's like this green bar on the bottom that needs to be filled. It will take quite a bit longer compiling for ESP32 if you compare it like with an Arduino. There's more to do, but there's also more functionality in the device itself. So I did not look at the code. I actually never seen this code, so it will be a surprise for me as it is for you. So with a bit of luck, we are able to use AT commands to dial the other numbers, the other number. So the phone that I have next to it, the Nokia 3310. Aha, I had a mate here. To you. Maybe it requires fixes. Yeah, maybe. Let's see. It is actually possible, and I did not do that, to show verbose information while compiling. So you actually see what it does. Yeah, I still have Granat. Actually, we do still quite have a lot of Granat. I have 2 crates here, but I got mine from RefSpace in The Hague. Oh, this looks very cool. Okay. If I only knew at that time. Okay, so let's turn the light off. Okay, and switch to the microscope view and zoom out a little bit. So this showed, so this is the factory test. The SIM card is okay. The signal quality is 15, which is quite high. There's a GPRS supported on this device. And there's support for USB serial and AT command pass-through. So this is already part of what we want to do. So am I able to read the bottom one? So I can, this is hard to read. Get IP and ping, and this is signal refresh. So can I get an IP? I actually can get an IP from the network. So this is Baidu. That's probably something that they put in inside the software. Let's see if I can. Yeah. Okay. So I was not expecting this to be returned from the provider itself. So let's go to screen view. Can I zoom in or out? So there's the Baidu part. So we have a device that is connected via serial to the computer, which states that it has good quality, is able to connect to the network, is able to retrieve an IP address, or connect to a website on the internet, and it allows serial communication. Huawei, not then. So let's go to serial monitor. So this is the serial monitor. So if I press send, what will happen? Nothing. Why will nothing happen? Because this is set to a certain baud rate. And if these baud rates do not match, you will not be able to communicate with the device. So since the UART communication is lacking a clock signal, you have to make sure that the baud rates align. So what I expect is that this will be 115200. Yeah, wrong baud rate, correct. So do a send again. AT. And we're in. Hacker voice, I'm in. So tell me, Joseph, what am I going to type? I heard that you spent quite some time looking at AT commands. Okay, let's try that. So not then states ATH0 and 3 pluses, which give an error. The 3 pluses is actually an interrupt to show that you need to stop the current communication and go to AT command. And the ATH0 will show ATH0 will show you the hang up. Now I need to scroll back to. Am I able to scroll back? Don't know. What was it that you said? DTMF. Yeah, you can do DTMF. So what I'm able to do, for instance, is I have the other phone here. So this is the other phone, the Nokia, and the Nokia had this phone number. So I needed the other one. So if I'm going to dial the other number, so 0682045519, and I'm pressing dial, then it will tell me ring 80. So I'm disconnecting it. So what it tells you is this is the caller ID. So it's +31 for the Netherlands, 6, and then this is the number that's calling the other number. Don't know what 145 is, but it shows me. Sorry? Yeah, Jure tells me that +1 is America. Am I able? Looking at two things at the same time. I'm wondering how you manage to keep up to date on your stream, not then, on all the previous tap and swipe left. Am I able to scroll back? No, leave it. Okay, so what I can do actually is I can dial again. So menu. PinePhone, nice. So it's actually not the phone list, but the last one. So I'm calling this one again. And you will see, let me clear my screen, clear output. And if I'm sending an ATA, which means hello, 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 then I actually, hello. Let me see if I somehow can show you hello, hello, hello. This is apparently not working, so let's add a hello, hello. So if I put this here, hello, hello, hello. So this actually works. So we have a connection between the Nokia and the M5 stack. So I have a connection now. So I want to break this connection. Apply, type 3 pluses and ATH0, which means disconnect. And now the connection is terminated. So if I do nothing and I just got a phone call, I will see the caller ID So I can show whomever is calling. I can use ATA to answer the phone. I can use ATH0 to disconnect the phone. There's some other things that allow you to send text messages, that allow you to create a GPRS connection, to make internet connections. Hey, I got a call. Hello? Who's this? Who's this? A guy from the chat. Yeah. This is how I met, if not Pike. And I really, really like that. Sharing phone numbers on your screen is always a good idea. Yeah. Yeah. Thanks for calling in. Okay. Bye. Yeah. That was to be expected, absolutely, and that was what I was hoping for. This is always fun. Cool. So this is what happens. Sending a text message, but I didn't want to waste. I think there's a 10 euros of value on the phone, so we can send a text message. So there's another phone next to it. So if you want to do proper OSINT and not share your whereabouts using my phone numbers. So if you can tell me, I want send a text to the M5 phone. Yeah, that would reveal your number. Hey Jan, nice. Thanks for calling. Yeah, no, never mind. I'm not into doxing people. I'm not Krebs. So what else are we going to do? Are we going to send a text message from the M5 to the 3310? Maybe sending it to me via Twitter might be more convenient for me to share it, other than reading it very quickly on the Periscope. Where's my... Here is my Twitter. Okay. Hey, Victor. Lol about Krebs, I think. Okay, Joseph, you had the idea of sending a text message. If this then that, yeah, absolutely, you could do an if this then that. You could actually the thing not then not then, but if not Pike, he created like a DTMF where he used the word time, which was 8, 4, 6, 3. You could dial the number and use some magic code on there to switch something on or off. So you could dial into your home, your cell phone number to switch on your coffee machine, or to restart your Minecraft server, or do whatever you want. So you're only limited by your imagination. So you could do whatever you want. And if this then that suits this a lot. So there's a lot of LoRaWAN, IoT module, cloud-based solutions, the text-to-speech, GSM, CAN bus. So you can even tell your car to use the windshield wiper, for instance, if you know what command to send over the CAN bus channel. So Joseph, are you sending me a DM with the AT command to use in the program to send a text message to the other phone? As I am lazy enough to do it myself. Pipe SMS directly to the Linux server logged in as a... That's always a good idea. curl piping bash. Please do that. It is 11 p.m. here. What I can do is, instead of going through all of these different ones, is use my original sketch. Let's see if I have it. Open. Take documents, Arduino old, M5 stack, GSM. CMGS. Okay, let's do that. 80 plus GMCS. Maybe I did not read it well. 80 GMCS is not doing anything. It's giving me an error. So what I did is, and I'm taking a shortcut here, is I'm using the M5 stack faces shield together with a calculator shield, this one. So adding this here. So now it's a calculator. It's compiling my sketch. Nice. People using burners all the time. Yeah. Love it. Yeah, that's the one. But that's all I could remember. Jan. Okay, this one is compiling. So as soon as it is done, I will put the these two parts on top of this one. So now I will have an interface to call the phone using the keyboard. Okay, resetting, done uploading. So I'm adding this one. And rebooting. So if you look here, let me give a wider view somehow. Will this work? Okay, so go to the microscope view, make it readable somehow. So this is my phone number. Oh, okay. Can I copy this? Yeah. Copy. Oh, let's keep that notepad. Okay. We use this as an addition to the current functionality. So what I did is, this is a calculator keyboard, so it has all the digits, but also like divided, multiply, minus, plus, equal, and some other buttons. So if I'm going to call this one, so that will be 0682045519 call. Oh, it's ringing. But I don't see it. That's odd. Okay. Okay. Hang up. Come on. Hang up. You can do it. Okay. Call again. Using my headphones. Incoming call. So the other one is calling. And now I need to answer. And if I look at my code. So answer. Answer phone. Oh, is this one. So answer the phone. Oh, I was not in time. I need to be faster. Okay. Again. Operation not allowed. So hang up. Oh. Hang up. Come on. Call. Answer. Yeah. And now I can hear myself over the phone. So this works. So now I can disconnect. So disconnect is set to equal sign. So pressing the equal sign. And now it's disconnected. So this is receiving a call. How about sending a call? So this one is 065. Are you able to? Yeah. 06589322386. And for dialing, what did I use for dialing? So this is dial number is a star. So now I'm dialing a number. So if I answer it, hello, hello, this will work. So if I look throughout the code to see how this works, I'll take you to the other screen. Maybe enlarge it somehow. Are you able to see it? Must be. Okay. So we're including the library for the M5 stack. The keyboard that is in here, actually, if you look at the bottom of the keyboard, maybe I can zoom in here. Microscope, where are you? I think this is so cool. We got a color, people. Nice. This is an Altmail. Come on. Always need to have a certain angle. So Atmel Mega 328P, which is an Arduino Uno. So this is a keyboard matrix that has an Atmel 328. You missed the stickers? You did not get them yet, or I gladly send them to you. And thanks for joining, by the way. This keyboard matrix is being read by this device, and if you look at the bottom of this, there's actually pin connectors to flash the keyboard matrix, but this is run by an Arduino and it communicates over I2C. So the keys are, this part are communicated over I2C to the ESP32. So there's actually an Arduino Uno inside an M5 stack faces. So if I go back to the code screen, you will see the keyboard communication is 8 hexadecimal and decimal. The interrupt that they use, so whenever you push a button, it needs to know that it needs to read it, is 5. The hardware serial module is using 16 and 17 for communication, RX and TX. I used a timeout from 10,000 milliseconds to make sure that it tries for a while for 10 seconds and then stops while sending a command. So this is actually sending the command. So a piece of code that's terminated by /r character return to communicate the information. So whenever I start, I initialize one wire, keyboard interrupt to pull up. I set the pin mode for the request to send, and I set the request to send to high. The SIM module communicates over 9600 bahts, and the first plus CME EE equals 0, and the false does show that you don't have to wait for it. So if it does not work, I don't care, just go on. Set the text color to white on black, print the date, set the screen on the background on black, show ready, and show the telephone number that the device is on. So this is hard coded, but I don't know if there's a way to retrieve the telephone number. I did retrieve a telephone number of a bellhead lying around, but it made me call a specific number, and the number was shown in the voicemail, so retrieve it digitally. So the dial string is empty, and this is a loop. I create a state machine for this. So while if the keyboard interrupt is low, this means that thanks. Yeah, it will be recorded, and don't throw it away. So you will be able to read through it or skip to the part that you missed. Thanks for joining, by the way. Cool. While the wire is available, and wire available means if there's I2C communication, it will read the data from the device. And if the data is not equal to 0, then there's data. So if this data is 0 to 9, it's one of the numerical keys. If it's A, then it's the AC that has been pressed. So there's AC, M, percentage, plus, multiply, divided, minus, equals, plus, minus, and dot. Those are the buttons that are on this device, and it will show them in here. So whenever you get a signal that some button was pressed, you will do one of the things. And if you press a button that is not defined, it will show a hexadecimal signal. So if I'm going here, and let's go back to the microscope view. So I'm pressing, let's put the light off. Off. Okay. So I'm pressing M, debug OX4D. So I can 4D. So 40. What's 40? 40 ASCII. Let me look at 4D. Oh. So 4D is an M. So actually the M is the character M as well. And if I press %, it will be 25. So 25 in hex is %. So if I press plus minus, it's 60, and 60 is less than. So if I press dot, it's 2e, and 2e is hexadecimal, come on, is dot. So we still have some features left. So I think it's cool to use the suggestion of Joseph to include sending an SMS. So let's do that. Okay. So go back to the code. So let's use the M for SMS. So I did not explain the parts of the state machine. So 1 to 9 will add the value to the string. A will remove a value from the string. Slash will answer the phone. Star will dial the phone number that is in memory. Dash will show the network, or minus. Plus will show the signal strength. Equal will show the hang up, and the default will be show the I2C information. Sorry for not switching the screens. Thank you for reminding me every time. Okay. Sorry, man. Okay, so again, 0 to 9 for the digits, A for the backspace, slash for answering the phone, star for dialing the phone number, dash for showing the network, plus for showing the network signal, equals for hang up, and the rest will show the digit that you pressed. So what commands did I use? This is like add a value to a string, remove the last character from the string. This is ATA for answer phone. This is ATDT and the number. So as ATD, I could also do ATDP for sending pulse information. AT plus cops. Reminds me of do not call the cops circuit board to switch lanes. and CSQ give me the signal of the quality of the signal, or ATH0 will disconnect the line. So let's add the text that we're going to send. So instead of doing the ATDT with the number, so this one, we want to send. So I'm adding this one, and I'm using the M for M equals send message, sending SMS. So this is the dial string, and the command that Joseph gave me was 80 plus C message equals and I see a quote, so I guess I need to add that one. I need to have the dial string, and that should include plus character return, and let's do a hi there and an end quote. So this should be what we need to do. 80 plus dial string /r text message quote and an enter to end the command. Okay, let's recompile the software. So remove the message. Yeah, I think we need to recompile it again. But this is just a proof of concept, and I should put it on Git, but usually I want Git to reflect what the quality of my software is, and this is not something that I'm very proud of. It's something that I just easily hack together. So that prevents me from getting it to Git. So, but on Git you can improve it, or can others? The letters are C message. Oh, sorry. CMGS. Okay. Yeah, that's exactly what you have sent. CMGS. C message. Okay. Good that you're still awake, Joseph. And thanks for joining the stream. Really appreciate it. Will be time that you come over here. Okay, done uploading. Okay, so this is my phone that I'm going to call. So I first need to type in the phone number. So that's 06 589 32386. And now I have to press M. So send message. Let's switch to microscope. Microscope. Invalid input type. Hi there. Okay. Yeah, you're right, Victor. You're right. But yeah, somehow I always think that next employers are looking throughout your code base and going to rant upon you. So what did I do wrong? 80 plus C MGS equals, maybe I do not need to put in the extra quotes. So I'm going to remove the quotes and see what happens. Actually, we could just flash the something happened or not. Okay. We could flash like the factory test to see if we are able to do it manually before programming it in there. But yeah, we need to sacrifice little kittens to the demo gods. Did not do that. Okay, again, 06. Let's do 5, 8, 9, 3, 2, 3, 8, 6, M. Sending SMS. Error, invalid input value. Okay, I'm done with it. Putting a delay between the AT command and the message text. Okay. Nice one, Victor. Okay. Let's see. Send SMS AT command. ATC. Okay. Maybe it does need to be with the international. So carriage return. Yeah, carriage return, not carriage return line feed. Send SMS. What I found, numbers. Yeah, there might be the plus 32, but I do not have a plus 32, so we need to implement that as well. So there was a plus at that one. So we have the digits, which are here. So copy. And the digits were, what was it, less than. So it needs to be less than. So less than 4 plus in, yeah, I know. I need to put it back to screen mode. Screen mode. So less than will add dial string plus. Then I need to put the quotes back. So that's 80 slash quote and the quote is around, okay, slash quote carriage return hi there. Okay. Okay, try it again. Oh yeah, should have read it. Thanks, not then. Okay, bye Jan. Thanks for calling in. Done uploading. Okay, back to microscope. So that's plus. Uh-oh. 60. What is 60? This something. Bye. 60. 60. Oh. So this is 60, which copy. I could do that another way. So go to this one. Again. Code screen, sorry. Screen. Yeah, works. Cool. Okay, webcam. No, microscope. So plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6. M for SMS. Invalid input value. Okay, I'm done with it. So we're going to use the other sketch. Factory default. Flash it. So here we are able to back to code screen, screen view. Okay. Signal refresh. SIM card. Okay. This works. Now I need to go to this COM11. Let's use PuTTY instead of the Arduino IDE. So come on, PuTTY. So that's serial 115200. Open. Why not? This COM11, right? Yeah, COM11. So is there's already stuff open? There's already stuff open. That does not work. PuTTY serial COM11 115200. Yeah. Okay. Right mouse click, change settings, appearance, change, apply, That's huge. Okay, right mouse click, change settings, default setting, save. So I don't have to do it every time. Okay, do is AT CMSG, the phone number, 5893238 6, and the message on the next line. Oh, but here they use the quotes on the same one. So invalid input type. So if I remove this one, copy, AT plus, no, C M AT plus C G S equals plus 3 1 6 5 8 9 3 2 3 8 6. Enter. Invalid. Doesn't have focus. Why? Okay. Okay. Quote. Quote. Plus plus plus. 8. Data. Yeah, it's in quotes now. Okay. Something happened. Okay, this is odd. Okay, this is funny. Okay, where's my screen? Microscope. So the message that I get is actually the AT command. Okay. So let's try it again. I think it might be the H. Which H? H. Control D. Is it Control D? Okay. Burning the message. Message 80. So if I'm sending this one, Control copy, Control D. Control Z. In the code screen, it is not. Okay. Read. E. Message. This. Read. Message. We're getting somewhere. So in the code screen, so this is actually what I'm pasting. Oh, I need to press a Control Z at the end. Okay. Enter. Control Z. Okay. Control Z. Let's try it without the press lezen. Let's just opties wissen. Okay. So plus 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 plus. Okay. Enter. And now I'm going to only do the ATCMS. So enter, Control Z. Read message. So this is how it works. Okay, cool. So we figured that out. So go back to the GSM. So we need to send the AT plus CMGS, the number with a plus 32. Then there's an enter. Don't know if carriage return is enough. Yeah, might be. And instead of enter, it needs to be Control Z. Maybe carriage return line feed. Oh, sorry. I need someone to switch the. Okay. So what I did is ATCM CMGS equals escape quote dialstream escape quote carriage return text Control Z and then carriage return line feed. So it states carriage return, maybe compile. So the trick was, and if I had properly read the documentation, I would have seen it. Oh, access denied because I had a putty session open. So don't open COM ports because the IDE. Yeah, you have much more experience now. Then I really would like to pick your mind on it one time. What the best way is to share it. I think I'm already in focus, but yeah, the resolution. A scene for like multiple streams is like people multiplexing it on Linux using Docker containers and. Don't know how you are concurrently sending out all the streams. Okay, so let's erase this one. No messages. So switch back to the telephone. Microscope view. So let's first use this one. So I'm pressing plus, and the phone number is 31658932386. And now I press M from SMS. Okay. Oh, nice. Yeah. It's like a subscription model, right? Restream. So this does not work. So if I'm sending hang up, maybe. So instead of carriage return, let's do a carriage return line feed. Yep. Switch back to code. Line feed. Carriage return line feed. Okay. Okay. Yeah. What restream, Victor, or what I just did? Like adding the carriage return line feed instead of just carriage return. Plus 31658932386. Send SMS. Okay. Okay, let's first see if we are still able to call. So C plus 3165889 32386, and what was dial again? Dial is the star. Okay. Important. Cache return line feed. ASCII 26. Cache return. Yeah, character 13. ATD. Why? ATC MGS equals quote del string quote where's my insert? Return. Hi there. Control Z. Maybe do a couple Control Z's. Maybe do a number of pluses. Okay. Is Control C the same as Control Z? I expect so, but assumption is the mother of all fuck-ups, is what I've heard. Oh, you cannot compile if you do not connect the connector. Control Z Arduino string. Sending Control Z character in for my AT command. Oh, seems like someone looked at it before. Okay. The person came up with this solution. 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6, M. Oh, it is in fact showing Z's instead of Control Z's. So might be a good one. So let's see what happens if we replace it with the /x version. Okay, done, done. Plus 3, 1. I could have automated this. 5, 8, 9, 3, 2, 3, 8, 6, M. Yeah, works. Oh, thanks, Crazy. This solved it. Read, read. Hi there. Hi there, Z. So there's probably still a control. Where's the Control Z then? Oh. Like old messages. Nice. Okay, so which means removing this one, and then I can remove this and this and this, and it does not need to be in line feed afterward. So this is enough. So carrots return, carrots return, carrots return, carrots return, carrots return, carrots return, carrots return. Okay, compile it again. Okay, done uploading. So let's try it without the plus. So it's 0, 6, 5, 8, 9, 3, 2, 3, 8, 6, M. No, it needs the plus 32. Okay, so that's plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6, M. Again, maybe it was not initialized. 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6. Send message. Error unknown. So why? Back to screen view. Carrots return. CMS error unknown. Okay, for the people that joined later, we're currently trying to make an M5 stack which are these devices, to send an SMS message. So we added a GSM shield, like this one, to the device, and we're now figuring out how to send an SMS text message. Okay, again, +31658. Oh, maybe first try the signal strength. Yeah, we have signal strength. Go back to microscope view. Hey Joseph. Okay, so we have a signal strength. So plus, AC, +658932386. Star for dial. See if that works. That works. So telephone is working. So plus 31658932386M. And now it's CMS error unknown. Hi there. Enter slash. Carriage return. It states carriage return. Why does it not work? ATCMGS equals escape quote dial string escape quote carriage return. Maybe do add a line feed. Carriage return line feed. Hey Cherry. So still 7 diehards in the stream. We're running for 4 hours now. Kudos for you. Free stickers if you will. Yeah, they are harder than they should be, especially the special commands. But you should like do this from a Linux terminal and do a octodump min-c to see what you're actually sending, to reproduce it. Like I'm now testing, compiling, running, all different things together. Maybe like the phone is not working yet. Okay. So plus 31658932386M. Not working. So if I'm sending this carriage return line feed, carriage return, so this is a carriage return, send this, so switch back to here. Copy and make a different command for the, so it has some pause in between. So hi there, and end with a, where's my special character? Copy. Okay. So this command. Okay. Try it again. Writing, resetting. Okay. Test the signal strength. We have signal strength. Plus 3, 1, 6, 5, 8, 9, 3, 2, 3, 8, 6. SMS. Ah, that did it. Okay. So, Joseph, you were right. It was about pausing in between the commands. So, let me move this aside. So, bericht ontvangen, which means message received, read, hi there. So it was been fixed by breaking the AT command up into different parts. One for sending the dial string, and then you need to wait a little bit, and then sending the text message with a simple Ctrl-Z. And the Ctrl-R, meaning character return, was enough. So we fixed it, people. Thank you. So as we're crossing the 4 hours now, I suggest we call it a day. Don't know if you have anything else or anything to share. Please do so. And Nodden, thank you very much for joining the screen. Time for beer, absolutely. I have some Belgian beer here. Thanks for joining and thanks for restreaming it. Really value that. Yeah, I think, and thanks for sharing. You say not then. I'm not. Yeah, I'm sharing it in the video, but I should actually share this code in Git. What you did miss, Joseph, is that your comment that you need to split it, that you have need some time in between, was actually the solution to this problem. So by splitting the code up in two parts, so let's go to the code so I have one dial string containing the telephone number, and the other one is the text. So by splitting it up in two separate commands, solved it. Thanks, Noden. Have an amazing one.